Hi everybody, we are going to solve paper 4, version 1, June 24. A long tube contains oil, small ball is held at rest at surface. At T0, ball is released, begins to fall vertically through oil. As ball begins to fall through oil, it accelerates, define acceleration, rate of change of velocity. Mass of ball is 0.0075. Calculate resultant force when it accelerating downward at 2.8. So F equals m times a 0.0075. As ball falls, V is recorded, Vt graph is shown. Describe what happens to acceleration between t0 and t.04. So at first, as we see here, the graph has a decreasing gradient until it becomes almost steady or horizontal. So gradient is decreasing until it becomes zero. This is because drag forces increases as velocity of the ball increases. Ball here is falling under its weight free fall, but the drag forces increases with the increase of velocity of the ball under the acceleration. But when these drag forces become greater than weight, acceleration becomes upward rather than downward, so it resists the velocity increase and reverse it to be decreased. By drawing a tangent, determine value of acceleration at t equals 0.01. So here at 0.01, we will draw small tangent and we will find the slope of this small tangent by finding 2 point coordinates on the line. So here's the first point with its y coordinate and x coordinate, and here's the second one. And to determine the y and x coordinate, we should find how much every small square is representing, whether on y-axis or on x-axis. On y-axis, it is 0.02 that represented 10 small square, so every small square is representing 0.002. Okay, and for the x-axis, it is 0.01 representing 10 small squares, so every small square here is representing 0.001. So to find the slope, we will subtract the y coordinates, which is 0.04 minus 0.32 over the x coordinates. Okay, the result will be, just make a mistake here since 0.0, and the answer will be 1.45 or 1.5 meter per second squared. Figure shows two identical trolleys, B and Q, held at rest on frictionless horizontal surface. A load is fixed to trolley B. There is a compression spring between B and Q. Trolleys are released, spring expands, pushes trolleys apart. Q moves to right at constant speed of 0.36. Mass of each trolley is 1.2 kilogram. Mass of load on trolley B is 1.5. Spring has negligible mass. Calculate speed at which trolley B moves to left. So it is clear that it is a problem on the conservation of momentum, where momentum before equals momentum after, and as it is before, the velocities of both of them were zero, so after the total momentum after the trolleys are released should also equal zero, and as each one of them moves in the opposite direction of the other, so we expect that after the trolleys are released, momentum of the first, which equals mq bq, sorry, vq, should equal the momentum of the second, which is mb vb. Now we will substitute, and we should take care that with respect to trolley B, it is its mass, which is 1.2, plus the load above it, which is 1.5. Okay, so VB will equal 116 meter per second. Okay, kinetic energy of Q, it equals half mv squared. So it is equal half times 1.2 times 0.36 squared. Answer will be state energy transfer takes place as springs expand. Energy transfers from elastic potential energy store to kinetic energy store of trolleys. Figure shows a small block of ice floating in warm water. State one way in which motion of particles in ice differs from particles in water. In ice, this is solid, so atoms vibrate around its position. In water, molecules or atoms movement is through the whole liquid. Energy is transferred from water to ice. State name of thermal process of transfer, it is conduction, certainly. Initially, 0.34 kilogram of water in beaker. Heat capacity of water is given. Calculate energy transferred from water as temperature decreases from 28 to 10. So Q equal mc delta T 1.34 times the temperature of water near ice decreases. First, explain how convection causes temperature of water in beaker to decrease. So as temperature of water near ice decreases, its density increases and it sinks down. Water at bottom of beaker with higher temperature has lower density and it floats up. Convection current is produced by upward downward movement. State what happens to internal energy of water as temperature of water decreases. Describe change in terms of particles. Internal energy decreases because it is the sum of both kinetic energy and potential energy, and the kinetic energy of molecules decreases as temperature decreases. Lens in a magnifying glass is converging. Figure shows this magnifying glass with its focal point. State what is meant by focal point. Point at which rays are collected after passing by converging lens if they incident parallel to principal axis. Student using magnifying glass to see magnified image of an object. Point X on principal axis for possible position of object should be between the focus and the lens. E for possible position of eyes student. We know that the magnifying glass will form virtual image, so it is the extension of the rays and the eye should be here. And the image formed will be virtual and upright. Refractive index of glass is 1.5, speed of air 3 times 10 to 8. Calculate speed of light in glass. N equals C over V. 1.5 equals 3 over V. So V equals. State what happened to wavelength of light as it passes into lens. It decreases because, as we know, N is equal C over V. It is equal wavelength in air times frequency in air over wavelength in glass times frequency in glass. Frequency in glass and frequency in air are equal because it's the same source that produce the light. This source vibrates at constant frequency, so refractive index is the ratio between lambda in air and lambda in glass, as this is greater than 1, so lambda in air is greater than lambda in glass, so in glass wavelength decreases. Converging lens used in spectacles glasses to correct one problem with vision. State name of problem and explain how converging glass is used to correct it. Name of problem. You should remember that converging glass helps eye lens to focus rays on retina, because without converging glass, eye lens cannot be powerful enough to focus rays on retina, and rays are focused behind the retina. And as I always remind you that eyeball have an opposite adjective to the disease. So when eyeball is short, the disease is long-sightedness. So converging lens, which help eye lens focus rays on retina, because eyeball is short, so the disease is long-sightedness. Don't forget this way of remembering how lenses fix eye problems. Describe how longitudinal wave differs from transverse. And longitudinal particles moves in direction of wave. Transverse particles move perpendicular. Here the wave, seismic wave state, whether it is B or S. It is B because it is longitudinal, and for S it is transverse. Remember that transverse have S letter, so it is secondary wave that is transverse, and certainly the primary would be longitudinal. Wave represented as wavelengths of 1.2 times 10 to 4 meter. Calculate actual distance between G and K. Between G and K, as we see, from G to here it is 1 lambda, and from here to here it is half lambda. So it is 1.5 lambda. So it is 1.5 times 1.2 times 10 to the power 4, which is equal 0.8. Wave in double I travels through ground at speed of 4,600 meters per second. As wave passes a certain point, the ground completes 5 oscillations. Calculate time it takes for wave to pass. Show your work. So as we know, V equals lambda F. So frequency is over lambda. So it equals, and as the ground completes 5 oscillation, and we need the time of this 5 oscillation, we must find the time of one oscillation. And the time of one oscillation is the periodic time, which is 1 over the frequency. And finally, 5 times 2.6 equals 13 seconds. Isolated metal ball suspended from an insulating thread and is negatively charged. Charge on sphere produces an electric field in surroundings. What's meant by electric field? Region where positive charge, or you can say charge only, can experience an electric force. Draw pattern and direction of field. It will be radial and arrows towards the ball because it is negatively charged. Magnitude of charge on a sphere is 3.5 times 10 to negative 10. Earth's metal wire is touched against surface of sphere and sphere is discharged. State what happened in wire as sphere is discharged. Electrons flows in wire from sphere to Earth. Takes 0.14 nanosecond for a sphere to discharge completely. Calculate average current in earthed wire. So current equals Q over T. Q equals 13, should multiply by 10 to the power minus 9 because he said nanosecond and nano is 10 to minus 9. Okay, and the answer would be in ampere, which is EMF battery is 7.5. Define EMF, energy needed to transfer a charge through the whole circuit. Battery is connected in series with a variable resistor and 30 ohm resistor. Battery is made using 1.5 volt cell. Draw a circuit diagram that shows all of the 1.5 volt cells connected to produce the EMF of 7.5. It will be certainly in series connection, or the negative of one cell is connected to the positive of the other cell. and as we want 7.5 from 1.5 cells, if we divide it by the calculator, we'll find that it is 5 cells. So 1, 2, 3, 4, 5. And the variable resistor and 30 ohm resistor, all of them are in series. So we will draw it like this. This is the 30 ohm one, and this is the variable resistor. Okay. The resistance of variable resistor varied from 0 to 150 using the diagram. The graph, here, show how current in circuit varies with resistance of variable resistor from 0 to 150. Determine and label value of maximum current on y-axis. So as we increase the variable resistor from 0 to 150, we expect the current to decrease, but from 0, this variable resistor has no existence and only 30 ohm resistance exists. So at 0, there must be a value for a current which is 7.5 over 30. Remember Ohm's law. So current here is V over R, V 7.5, R 30, and the is 0.25 ampere. This will be the maximum value, and then the current decreases as the resistance increase. Okay, because from Ohm's law, this value is constant V, so both I and R must be inversely proportional to each other, and there is a multiplication, so the graph should have this form. Isotope thallium decays by beta, complete numbers. Beta have -1 in its atomic and 0 in its mass. So lead here should have +1 over this number to have this equation balanced, and the mass number is constant, and you should remember that beta decays resulted from a neutron decays to proton, and beta goes outside the nucleus. So outside the nucleus, the mass number or the total nucleon number is constant because one neutron is replaced by one proton, so there is no change. Beta emission of thallium is accompanied by gamma emission. Explain why gamma doesn't affect numbers in equation. Because it is electromagnetic wave that has no mass and no charge. Suggest one reason why nucleus of thallium is unstable, because neutrons number is greater than protons number. Sample of thallium is placed in thick lead container, narrow beam of beta and gamma emerging from it. And here is a magnetic field that both beta and gamma will enter. Draw a line labeled beta to indicate path of beta and another one to indicate path of gamma. So gamma will pass straight away without no deflection, horizontal, but beta will deflect. The question here is where it will deflect, upward or downward. You should remember Fleming left hand rule, where first finger goes in direction of field, and the field here is into page. So here is the direction of first finger, and second finger goes in direction of current, and direction of current is the opposite of the direction of electrons. So as beta particles or electrons is moving in this direction, the current will be moving in the opposite direction. So here is the second current, okay, the second finger, which is current. So just your hand, you will find that your sample will goes down, so the bus of beta will be down. Sun is one of many billions of stars in Milky Way. Sun emits a very large quantity of energy as EM radiation stays three regions of EM spectrum in which Sun emits: UV, visible, and infrared. EM radiation of Sun travels at speeds, light speeds, vacuum. Radiation takes 500 seconds to reach the Earth. Calculate distance. Regular V equals d over t problem. So d equals answer will be, which you might remember it as 150 million kilometers. Approximately 4.6 billion years ago, Sun formed from interstellar cloud and becomes stable star. Describe and explain what happens as interstellar cloud of gas forms a protostar. So gravity pulls molecules from the cloud. Addition pressure caused by high temperature produced from fusion pushes the molecules outward. Describe and explain what happens as protostar becomes stable star. It occurs when inward gravity forces equal the outward radiation pressure. Okay, that's all. Follow me on my channel and Facebook page to keep knowing about the news. Thank you all.